Hello there and welcome to Lower 6 Maths A-Level Practice Paper D. Here we're on the last question, a vectors question. OACB is a parallelogram. O to A is the vector A, and O to B is the vector B. MS, N and T divide OB, BC, CA and OA in the ratio 1 to 4. So with each of these, whenever you have a fraction in a vectors question, always consider the fractions on each of the different parts here. So if we've got 5 parts in total, splitting them up in the ratio of 1 to 4 will give it 1/5 and 4/5 as fractions. Express m to n in terms of a and b. Okay, so what we have to do here for m to n is we're going to have to go from here to here. So we have to go round the outside where the a's and the b's are. So we have to go 4/5 of the way along b. So that's this way. Then we have to go along an A to get to here and backwards along a 5th B. So it'd be add A, take away a 5th B. So simplifying this, we're going to get 3/5 B, add A. Okay, great. Part B, find the vector from S to T. So we're going to do this in a very similar way. So we're going to start at S. Let's work along 4/5 of A, and then down B, so take away B, and then back a 5th along A, so take away a 5th A. So simplifying this, we're going to get 3/5 A minus B. Okay, so moving on to the next part, show that the lines M, N and ST intersect each other, and the coordinate D here is the intersection of the two lines MN and ST. So I'm just putting those 5ths and 4/5 back on my diagram here. So what I'm going to do in this question here is I'm going to find two different ways. So the strategy is find two different paths from O to D using what I've found so far. So just recapping what I did over here, M to N is 3/5 B add A, and S to T was 3/5 A minus B. That will come in handy later on. Okay, so the first way I'm going to get to D is I'm going to go up to M and then M to D. So I'm going to split up my route from O to D in O to M as a vector, and then I'm going to get from M to D. Now the way that I get from O to M, that's just a 5th B. And then I'm going to add on the line to get from N to N, but just some fraction of it. So what I'm going to do is I only want to get to here, and this is going to be some fraction, we'll call it mu, of the line from M to N. And hopefully if mu is a half, then we have a bisector. If it's anything else, we don't have a bisector, but it's going to be some fraction of the line from M to N, and M to N was 3/5 B plus A. Okay, so if we were to go all the way from M to N, our ratio would be 1 here, but we only want to be going a fraction of that distance. So just remember here that mu is a fraction. So it's a fraction of the way from m to n. Okay, so a different way of getting, let's simplify this now, group all the a's and the b's together. So it's going to be mu a add a fifth add 3/5 mu b. Okay, so a different way of getting from O to D is to go from O to, we've got a vector from S to T. I think it'd be better to go from to T and then up to D here. So we're going to go from O to T, and then we're going to add on the vector from T to D. And that's how we're going to get from O to D. So the first way we get from O to T is going 4/5 of the way along A. And then we're going to add on T to D, which is some fraction, we'll call it lambda, of the vector from T to S. Now if we've gone from S to T here, the way we go from T to S is we can just negate things. So it's going to be B minus 3/5 A. Okay, so this is going to be 4/5, simplifying it. 4/5, take away 3/5 lambda A plus B lambda B. Okay, so we've got two different ways that we can get from O to D. Now if there are two different ways to get from O to D, then those vectors must be equal to each other. So given that O to D must equal O to D, we know that this way of getting from O to D must be the same as this way of getting from O to D. So we can say here that mu A add a fifth plus 3/5 mu, lots of B, needs to equal, running out of space here, 4/5 minus 3/5 mu, lots of A, plus lambda B. Okay, so we've got this vector here must equal this vector here. And if the two vectors are equal to each other, then the A parts must be the same as each other and the B parts must be the same as each other. We can create two simultaneous equations out of this. So from the left hand side, mu must equal what we have for A on the right hand side, 4/5 minus 3/5 lambda. And for B, our B component on the left, a fifth plus 3/5 mu needs to equal lambda B. So just lambda there. You could write the A's included in these equations here, A's and the B's, but you don't need to because they'll all cancel out. Okay, what I'm going to do with both of these equations now, I'm going to times everything by 5, just so it's all integer values. So it's going to be 5 mu equals 4 minus 3 lambda, and this one here is going to be 1 plus 3 mu equals 5 lambda. Okay, so what I think I'm going to do now is, with this equation here, I'm going to set this equal to 3 mu equals 5 lambda minus 1. So take the 1 over to the other side on this second equation, and then times this equation by 3, and this equation here by 5. So with the first equation, I'm going to get 15 mu equals, so what I'm trying to do is I'm trying to solve two simultaneous equations to work out what lambda and mu are. And if lambda and mu both come out to be a half, then that's perfect, because then that bisects the line of S to T and M to N. So 15 mu equals 12 minus 9 lambda, And the second equation is 15 mu equals 25 lambda minus 5. So now that we've got two expressions here that both equal 15 mu, we can set them equal to each other. 12 minus 9 lambda equals 25 lambda minus 5. Add the lambda to the other side, you get 17. Add the 9 onto the other side, you get a 34 lambda. So divide through by 34 and you must get lambda equals a half. Okay, plug lambda back into one of these earlier equations and you get 3 mu equals 5 lots of a half minus 1. So that's going to be 2.5, so it would be 1.5. So then mu must equal a half here. Okay, so we've proved that mu and lambda equals a half, just as we wanted here. So now we need to write some sort of conclusion to finish this answer. So as lambda and mu both equal a half, to get to D, D must therefore bisect M to N and S to T. Okay. Okay, yeah. Okay, so that's the answer to the question. 13 marks for that one.